In this video, we're going to take a look at the graphing problems in Module 9 of College Prep Math. So I went to the practice test for this module and I just grabbed every problem that had any kind of graphing going on. In this particular problem, we're not being asked to graph, but there is a graph provided and we have to use that graph to answer the question. So I thought I'd go ahead and put this one on here as well. Now, the way we have the test set up is, okay, I'm not sure it's recording. All right, so the graph shows the sales of product A and product B in millions. Use the graph to answer the question. The dotted line represents the sales of product A, so that'd be this product here. The sales are increasing over time. And the solid line represents the sales of product B in the graph. So here's the solid line. It's declining over time. In what year were the sales of product A about the same as product B? So the sales would be the y-axis, the years would be the x-axis. So where they're the same or about the same would be where they have the same y-coordinate, which is going to have to be where the two lines cross each other. So for this particular problem, what you want to do is find where the two graphs are crossing, which would be about right here. And then look for the coordinates of that particular point. So if I look down here to the x-axis, I get that it has this x coordinate here, which looks like the year 2005, right? This is 2004, this is 2006. So this would be the year 2005, all right? So that's the x coordinate. The y coordinate we would get by looking over here to the y-axis, and it looks like it's about right here between 400 and 600. So it's going to be 500, and this is in millions, so it's 500 million, but the answer over here already has the millions acknowledged, so we can just like they do in the graph, so we could just use 500 as our answer. So where the graph crosses, where the two graphs cross each other is at 2005, 500. So 2005, that's the year, that's the time. And the 500 is the sales, right? So the x coordinate is the year, the y coordinate is the sales. So in 2005, the sales of product A and product B were about the same. I kind of read that wrong, but it says the same thing, which were blank millions of units. And so here you type in 500. So that's how you get the answer for this particular problem. All right, so again, the problems are scrambled. They're in a, random order. And so this is really kind of material that you do at the end of the module, but it was near the beginning of the test that I generated. And so here we want to graph the solution set to this system of inequalities. So to do that, there's three things you want to accomplish. First, you want to graph. Okay, let me start with this. What I would recommend, which I'm not really liking by looking at this, but I think it's still the best way to do the problem, is solve each of these for y. That is the way I recommend doing these. And I think I saw one later in the test where we may not be able to do it that way very well. But this one I think will still work out okay. All right. So the first step I'd recommend is solving both of these for y. The first one is already solved for y, so we're good there, right? It already has y by itself. But the second one, we want to solve this for y by subtracting the 8 to the other side. And so we'll get x minus 8 is less than 4, and then divide by 4 on both sides. Now make sure when you divide by 4 on both sides, this entire thing gets divided by 4. So what's going to happen is the 4 will divide into each of these separately. So we'll get x over 4, which we can write as 1/4 x, minus 8 over 4, which gives us 2. And then here the 4's cancel out, and so we'll have less than y. And this is solving it for y, but if we leave it like this, it's going to be hard to interpret and get the answer that we're supposed to get. So I would also recommend having y on the left-hand side. So what I want to do is kind of just switch these things around, flip it around, get the y on the left-hand side, get the 1/4 x minus 2 on the right-hand side. The thing about inequalities is that when you flip an inequality around, the symbol has to also get flipped around. And so this less than gets flipped around and becomes a greater than. The way I like to describe it to my students is, if you think of the inequality symbol as like a mouth that's opening up, the mouth has to open up to the same thing, whichever way you decide to write it. So here the mouth is opening up to the y. So when I flip it around, the mouth still needs to open up to the y. So that's why it gets flipped around as well. All right, so here's my second inequality right here. Here's my first one. All right, so that's step one. Have both of the inequalities solved for y. It's going to make the rest of the problem easier. So I know that's kind of a lot of work up front, but it's going to pay off here in just a minute. Step two is to graph, sorry, I had a little glitch there, graph these as if they were equations. So we're going to graph y equals 3x minus 4, and we're going to graph y equals 1/4 x minus 2. So we have to think back to a previous module where we learned how to graph these kind of equations. And so these are linear equations. Because we solved them for y, they fit this formula of y equals mx plus b. B is the y-intercept. M is the slope. And so we'll use that information to graph these as equations. And so the slope in this case is 3, which we can think of as 3 over 1. That's going to give me my rise over run. B is -4, and so that gives me the y-intercept 0, -4. So you start at this point, you apply the slope. It's like a set of directions that tells you how to find another point. But you have to have a point to start from first in order to do that. So we start from 0, -4, which is right here. It's on the y-axis. It's the y-intercept. The slope is 3 over 1, so it gives me the set of directions to go up 3 to the right 1. So starting from here, I'm going to go up 3 to the right 1, and I get this point right here. And so there are 2 points, and with 2 points, we can graph the line. So let me switch tools here to better draw this line. I'm going to hopefully draw it as straight as possible. So let's do something. Oh, okay, I moved it right at the last second. Let's try it again. Okay, let's see if I can do that. Okay. And of course it goes in both directions, so it'd go this way as well. And I'm sorry if it looks a little disjointed. So it should be more like right there. In fact, I might just redraw this. Let's try it one more time. All right, that's still a little bit off too. All right, so I'm trying to line these two ends up here, and I kind of know from the slope where this should end up. So this is a little bit better. If we go down 3 into the left 1, we should get this point right here. So that's why I'm trying to make sure I hit that point. Okay, so there's the first equation. Now let's graph the second equation, right? And so we have the y-intercept here is, whoops, forgot I have the straight line tool. Let's go back to the pen. Here I have 0, and I'm sorry if you can't see this. I lost my border for my recording area. It disappeared on me, which is why I kind of glitched earlier. And so I don't know exactly where the boundary is for my recording. So I'll scroll up just to make sure it's visible to you. So the y-intercept here is 0, -2. The slope in this case is 1/4. So we're going to start at 0, -2. And then we'll go up 1 to the right 4. Right. So starting here at 0, -2, up 1 to the right 4 is going to give me this point right here. And then I'll connect those 2 points with a straight line. And that gives me that graph. All right. Okay, and again, it's not perfect, but close enough, hopefully. All right, now that's step 2. Right, so step 1, solve both of your inequalities for y. Step 2, graph them as if they were equations to get these lines. Oh, I made another mistake. Okay, so the other mistake I made is my second line should be a dashed line. So let me see if I can reverse that. And so I forgot about this detail. I apologize. So if there's an equals to, when you graph it, it should be a solid line. If there's no equals to, you should graph it as a dashed line. It's like when we do inequalities. If there's an equals to, we use a bracket. If there's not an equals to, we use a parentheses. It's the same idea. It's whether the line is included as part of the solution set or not. That's what we're trying to indicate there. So I wonder if I have that option. No, it doesn't look like I do. So I'm going to have to draw this by hand as a dashed line because this software does not allow me to do dotted lines when I draw a line. So let's see. So this line might not look as good, but we got to make it dashed. All right, so there's our dashed line right there. Okay, connecting those 2 points. Now, so step 1, solve both for y. Step 2, graph them as if they were equations to get 2 lines. Step 3 is to shade in the region that satisfies both of the inequalities. And because you solved both of these for y, it's actually pretty easy to determine where we should be shading in. You go back to your inequalities here, and if you have y is less than your equation, so I don't know if I'm saying that right, but if it's y is less than, you shade below that line. All right, so this is a less than here, which means for the first line, which was my red line, I want to shade below that line. And so less than means I should shade below that particular line. Greater than means I should shade above. So I'm going to shade below the solid line, but above the dashed line. All right, so this is step 3, deciding where we should shade in. And so I need to shade in the region that satisfies both of these because I'm trying to get both of these inequalities to be true. So I have to do both of these things. I have to shade below the solid line, but above the dashed line. And so the region that meets both of those criteria is this region right here. Right? This is below the solid line, right? Looks like it's kind of to the right of it, but it's below it as well. But it's above the dashed line. Right? So this region is the only region that does both of those things. It's above the solid line, but below the dashed line. So every point in this region will satisfy both of these inequalities. So we want to shade in the entire region. If I pick any point in this region, it will make both of these inequalities true. Right? And so that's what the graph should look like. So there's a lot of details there, but that's the process you want to follow. Solve both for y, graph both as equations, and then either shade above or below, depending on whether you have less than or greater than for each of your equations. All right, let's look at the next example here. So here, this is not an inequality. These are equations, and they want us to solve this system of equations by graphing. So again, we want to graph both of these equations. We have x plus 2y is equal to 6. We have 2x plus 4y is equal to 20. Because these are not inequalities, I don't need to solve these for y. Not that it would be so bad to do that. I think these would work out pretty nice still, but it's not required. We don't have to solve these for y. We just need to graph them, which means because these are linear equations, we need 2 points. 2 points, we can graph a line. And the easiest 2 points we can get from an equation that's written in this form are the x and y intercepts. Right? So the x-intercept, we find that by plugging in 0 for y. Right? So the y-coordinate will be 0, and then we need to find the corresponding x-coordinate in that case. Right? And by plugging in 0 for y, it just makes this term disappear. Right? We'll get 2 times 0, which will be 0. And then we'll have x plus 0 is equal to 6. Well, the 0 just goes away, and we get x is equal to 6. So what's quick about this is that when you plug in 0, that term just disappears, and you can just mentally get the answer. Right? This term goes away, x is equal to 6. Right? That's the x-intercept. We also want to find the y-intercept, which you do by plugging in 0 for x and then solving for y. All right, so let me see if I can restore that. So I wanted to erase the 0 that I just used. All right, so for the y-intercept, we're going to plug in 0 for x and then solve for y. When I plug in 0 here, this term just goes away, and I just get 2y is equal to 6. Right? Because this 0 will just disappear. And then to solve this for y, I divide 2 on both sides. So again, it's some work, but it's work you can do mentally. Right? Divide it by 2, you get y is equal to 3. Right? Now I have 2 points for this equation. I can graph this line. Right? So we have 6 comma 0, that's on the x-axis, that's the x-intercept. And then 0 comma 3, that's on the y-axis, because that's the y-intercept. And again, connect those 2 points with a straight line. And you want to make sure you're doing this precisely. Now on Math Excel, it's automatic. Once you select the line graphing tool and you put 2 points, it automatically draws the line for you, and it's a perfectly drawn line. But when you're doing it by hand, you got to do it very carefully if you want to get the right answer. So hopefully this is going to be accurate enough for us to figure out the right answer. We'll see. Okay, so that's the first equation. Now we need to graph the second equation. We'll do this one in green. We'll do the same thing. So we have the x-intercept, the y-intercept. So we're going to plug in 0 for y to get the x-intercept. We plug in 0 for y and then solve for x. If I plug in 0 for y, this term goes away. I just get 2x is equal to 20. I divide by 2 on both sides. I get x is equal to 10. To find the y-intercept, I plug in 0 for x. That term goes away. I just get 4y is equal to 20. Divide by 4 on both sides. I get y is equal to 5. And here's my 2 points. So we have 10, 0, and we have 0, 5. We connect those 2 points with a straight line. Okay, let me try that one again. It's a little bit off the point there. Okay, that's a little bit better. And what you're noticing is that these two lines are not going to cross each other. And it'll be more noticeable on Math Excel when the lines get drawn well. I'm trying my best here. Okay, so there we go. That's a little bit better. These are parallel lines, right? And when you graph in this way, you might not notice it, but you should notice it if you were to solve both of these for y, because you'll see that they both have the same slope. And if the slopes are the same, the lines are parallel, which means they don't cross each other. So this is maybe a bad first example of graphing for solving a system of equations, because the point of it is the solution to the system of equations is where the lines cross each other, right? And if they don't cross each other, there's no solution. So if you get parallel lines when you graph, that means the system of equations has no solution. Right? The solution is where they cross each other, and if they don't cross, there's no solution. All right, and so for this problem, you see there's options here that don't quite get displayed on the screen. Option A is if you do have a solution, you type it in there. Well, we don't have a solution, so we don't choose option A. Option B is if there's infinitely many solutions. We don't have infinitely many solutions. We have no solution at all. So option C is the option you want. It's not on the screen, unfortunately, but you want to pick option C here, which is that there are no solutions. All right. And so it might say the solution set is empty. It might use different wording, but it's indicating there's no solution to this system of equations. All right, so if you have parallel lines, no solution. All right, same problem, hopefully a different outcome this time. So we have negative 3x minus 2y equals 6, and we have 3x minus y is equal to 12. We want to graph this system by, sorry, I said the wrong thing. We want to solve this system by graphing. And so we will use the same technique as the last problem because it's set up exactly the same way. We'll do x and y intercepts. So we'll do x-intercept, y-intercept. Hopefully that all fits on the screen okay. I'm going to scroll down just a little bit though, just to make sure. All right. And so let's see if we can do this mentally so I don't have to write down as much. I can get through this a little bit quicker. The x-intercept, we plug in 0 for y. That term goes away. You get negative 3x is equal to 6. You solve that for x by dividing the negative 3 to the other side, and you'll get negative 2. All right, so we plug in 0 for y, and then I'll go ahead and write this one down. We get this, right? When we plug in 0 for y, that term goes away. We just have negative 3x equals 6. Divide by negative 3, you get that. For the y-intercept, we plug in 0 for x. That term goes away. We just get negative 2y is equal to 6. Divide the negative 2 to the other side. You get y is equal to negative 3. Right, and so that's our x and y-intercept. So we have negative 2, 0 on the x-axis, and 0, negative 3 on the y-axis. And then we connect those 2 points with a straight line. And that's graphing the first equation. Hopefully that's good enough. For the second equation, we'll do the same thing. X-intercept. Whoops, I still have the straight line tool, which is okay for the first couple of letters here. X-intercept and y-intercept. So the x-intercept, we plug in 0 for y, so the y-coordinate will be 0. We get 3x is equal to 12. Divide by 3, you get x is equal to 4. All right. To find the y-intercept, you plug in 0 for x. So we plug in 0 here. That term goes away. We get negative y is equal to 12. You have to divide by the negative sign to the other side. This one's kind of tricky. Divide by the negative, negative 1 if you will, and you get y is equal to negative 12. All right, so we have 4 comma 0, which is on the x-axis, 0 comma negative 12, which is right here. And this time you can see we definitely do not get parallel lines. They will cross each other pretty directly here. So this would be the graph of the second equation. As I mentioned in the last example, the solution is where the graphs cross each other. And so if we've drawn our graph correctly, hopefully we'll get the right answer here. So they cross each other about right here. And I'm expecting to get a reasonable, nice answer. And so if my drawing's a little bit off, I think we're just going to kind of round it to the next nicest answer. On Math Excel, it should be very obvious because, like I said, Math Excel will draw these lines perfectly, and you should be able to see perfectly where they cross each other. This, to me, looks like it's going to cross at x equals 2, right? So it looks like the x-coordinate here is going to be 2. And then the y-coordinate looks like it will be negative 6, right? It's halfway between negative 4 and negative 8. So that looks like the point where they will intersect each other, and that will be the solution to my system of equations. And so it's going to be option A, and you would type this in as an ordered pair. So make sure you don't want to get it wrong because of a typo. Make sure you use parentheses and a comma between the two numbers when you type it into the box. All right. Here's another one. So here, I would like to use the same technique. This is the one I was thinking about where I was like, oh, it's not going to work out well either way, actually. So whether I do x and y intercepts or if I do solving it for y, these equations are not very friendly. I'm trying to think of the best way, because what you need are 2 points. One way to get 2 points is x and y intercept, like we did the last couple of examples. Another way to get 2 points is to solve it for y. You start with the y-intercept and then you use the slope to get a second point. So those are the most common techniques for getting points. But you don't have to use those techniques. You just need 2 points. It doesn't really matter how you get those 2 points, as long as they actually work on the equation. Right? So you can't just make them up, but you can extract them in whatever way you think would be most convenient. So here I'm just trying to think what would be an easy couple of points for me to find for graphing this. So we have 5x minus 4y equals 1. We have 15x minus 12y is equal to 3. And so I need 2 points for graphing this first equation. And I see one right away, and I don't know, it might be the best one. No, there's another one I could think of that. No, I don't know if that works actually. So really, you want to get 1 here as a result. So yeah, this one's hard. This one's hard to graph. Because if you do x and y intercepts, you get fractions. And while that in theory is not an issue, you can graph points that are fractions on paper. You really can't on Math Excel. You have to have nice numbers for the graphing tool to work. And you really want nice numbers even on paper, you know. So, I don't know, I'm just trying to think here. Yeah, so the one that I see, and so it's like, what's a good process to use here? You just have to kind of look at the numbers to figure out what might work out nice. Is if we choose x equals 1 and y equals 1. I can see that's going to work out nice because I'm subtracting and I want the difference here to be a 1. So these need to be 1 apart from each other. So when I subtract them, I'll get 1. 5 and 4 are already 1 apart. So I just want to keep these numbers the same. 5 minus 4 would give me 1. So to keep the numbers the same, I plug in 1 for both of these, right? We'll get 5 times 1 minus 4 times 1, which equals 1. 5 minus 4 is going to be 1, so it comes out true. So this would be 1 point that works. Right. which would be 1, 1. But you still need another point. And that's where I'm actually kind of stuck myself, is what's another way I could get these to be just 1 apart from each other. So I'm trying to think of multiples of 5, multiples of 4. So here's another one. 25, right, is a multiple of 5. We can get 25 here by plugging in 5 for x. And then 24 would be a multiple of 4. So if I can get this to be 25 and this to be 24, 25 minus 24 would also be 1. How do I get this to be 25? I plug in 5 for x. Right? And how do I get this to be 24? I plug in 6 for y. Right? And then they'll be 1 apart from each other. And so that gives me 5, 6 as a point. So there's 2 points that work in this equation. I can use that to graph the equation. So 1, 1 and 5, 6. Which I'm having trouble lining this up exactly. I think it's right there. Okay. All right. And then you connect those with a straight line. All right. So that's the first equation. Got to graph the second equation. Whoops, I keep forgetting to switch back to the pen. All right, so I'm going to divide these. And I'm sorry, I don't know if you can see all the things I wrote here, so I'm going to scroll down a little bit more. Okay. Now, for this one, you got to find 2 points. And so, same issue, right? If I try to do x and y intercepts, it's going to be a fraction. I can't use that to graph on Math Excel. Plus, I wouldn't want to graph it on paper that way either. If I solve it for y, it's not going to help. Same issue. So again, I'm looking at trying to guess numbers here that I think will work out. And again, I see the same pattern I see over here, which is I want to get 3 as an answer, and I'm subtracting these 2 things. So I want them to be 3 apart from each other. So when I subtract, I'll get 3. Well, the numbers that are already here already fit that description, right? 15 minus 12 would give me 3. So I want to keep these numbers the same. That's one way to make this true. The way you keep them the same is to have x equal to 1 and y equal to 1. So 1, 1 works, right? So again, you'll get 15 times 1 minus 12 times 1. That'll be 15 minus 12, which does equal 3. So that's 1 point. So it happens to be the same point that we already had here. So right there, we have 2 points that these 2 equations share in common. Not 2 points. We have 1 point that these 2 equations share in common. But let's go ahead and finish graphing this line. So again, I'm thinking multiples of 15, multiples of 12 that are 3 apart. So another one that's going to work would be, so 15 would be 15, 30, 45. Now 12 would be 12, 24, 36, 48. 45 and 48 are 3 apart, but backwards, right? That'd give me -3. So unfortunately, that doesn't work. So let's maybe make a chart here, right? 15, 30, 45. These are multiples of 15, which I can easily get here by choosing the right number for x. 60, 75, 90, right? For 12, we have 12, 24, 36, 48. And I just need 2 numbers here where the one in this column is 3 bigger than the one in this column. 48, 60, so they actually match each other. That's not good, right? 72, right? So 72 and 75 are 3 apart from each other. So when I subtract these, I would get 3. So how do I get 75? By plugging in 5 for x, right? 15 times 5 gives me 75. And how do I get 72? By plugging in 6 for y. If I plug in 6, it's the 6th one on this list. 12 times 6 gives me 72. Well, that's weird, right? Because that's the same exact 2 numbers that we had over here. So what you're finding, and I kind of knew this was going to happen because I could see these equations are actually the same equation twice. All they did was take this equation here and multiply it through by 3. But it's really the same equation. And so we're getting the same points, which means we're going to get the same line. So if you try to graph the second equation, it just lays right on top of the first equation. The first line, right? So really it's just the same line twice, which means this is all you have to graph for this particular problem because you're just getting the same line 2 times in a row. So there's just one line to show for this graph. And whenever that happens, if you get the same line twice, that means you have infinitely many solutions. So you want to choose option B. And then I can't remember, let's see what it asks for here. And so then you type the equation in. I don't think you have to solve it for y. So you can see like from the previous example, they want you to type something into a box here. So if you choose option B, there's something to type into the box. You want to type the equation. Now you might say, which one? It's the same equation. It doesn't matter which one technically, but I would use the one with the smaller numbers. So you choose option B, and then in the box here, you're going to type in, it'll have something like this. The solution set is any x comma y such that, and then it'll have a box for you to type in the answer. You'll type in 5x minus 4y equals 1 into that box. And what you're saying is that basically any point that works in the first equation automatically works in the second equation. So it's a solution to the system. So any point that works in this first equation is a solution to the system. So all of these points here, there's infinitely many points. It doesn't mean that any point works, right? 0, 0 still is not a solution to this system, but there are an infinite number of other points that do work. They just have to be on this line right here. All right. So I'm sorry this video is taking a little bit longer than I thought it would. I was like, oh, I'll get on there, spend 10 minutes and go through those few problems, but it's been a little more lengthy than I expected, so I apologize for that. But hopefully you find it helpful, and this will help you with passing the post-test for Module 9. So for the last example, this is the last one on the practice test in the order that I got them in that had to do with graphing. And this one's, we did one like this earlier. It's a system of inequalities, but what's nice about this one is they've already graphed the inequalities for you. All you have to do is shade in the proper region. Now, what you could do is use the other method for solving a system of inequalities, which is the test point method, which I think is the way MathXL likes to explain to do these problems. And the test point method is once you've graphed both of the equations from your inequalities, you test each region by picking a point in that region. So for example, if I want to test this region here, I just pick a point in this region. So I could pick this point here. This is at 4, -3. And then you test it by plugging it in to make sure it works in both of these inequalities. If it does, you shade in the whole region, because if this point is a solution to this system, then every point in this region will be a solution to this system. So if one point works, they all work in that particular region. So you'd shade them in. You shade that region in. And so you keep testing until you find one that works. So you might be lucky and the first point you pick works. You shade that in and you're done. But if this point doesn't work, well, I got to test this region, which of course the best point to choose here would be 0, 0, right? And then see if that point works. If that point doesn't work, then you got to test this region, pick a different point. And test that one. If that one doesn't work, well, then I guess by elimination, you know, it has to be this one. But so you might get away with just testing one point, or you might have to do maybe up to 3. I still favor the other method that I did earlier, which is solving both of these for y. And then that will tell me which region to shade in without having to plug points in. So this first inequality is pretty easy to solve for y. Subtract x to the other side, you get this. Because y is greater than, I want to shade above this particular graph. Now what I'm going to have to do is figure out which of these graphs corresponds to this inequality. Right? So here the y-intercept is 3, the slope is -1, so it has to be this line here. This one has a y-intercept of 3, and so this is y equals 3 minus x, this line right here. And so that's the one that corresponds to this inequality, and I want to shade above this line. So it's either going to be this region or this region. These are both above the line. Now the other one's a little bit more difficult to solve for y. You subtract 4x to the other side, and you get -5y is less than 20 minus 4x. So again, I'm sorry, I've lost my boundary indicator, so I don't know exactly where the screen stops recording. So I'm going to scroll down just to make sure you can see what I'm doing. And I don't know, it's weird. I haven't had that glitch yet. I've recorded several videos, and that's the first time that glitch has happened. So I don't know what's going on. Then you divide by -5 to solve for y. Now what's significant about that is if you divide by negative on both sides, you have to flip the symbol around the other way. That's why you still have to go through. You might say, why do we have to bother solving for y? Just look at the inequality symbols. that works for the first one, right? If you just look at the original, it's a greater than, shade above. That's what we ended up concluding here. So why wouldn't we do that for the bottom one? It's a less than, so shade below the other one, because when we solve it for y, we divide by negative on both sides. That's going to cause the symbol to flip around the other way. And then this negative 5 divides into both of these, so we get 20 divided by negative 5, which is negative 4. Negative 4x divided by negative 5 will be positive, because negative divided by negative is positive. And then we'll get 4/5 x, right? And so that's the second inequality. Because that's a greater than, we actually will shade above in this case as well. So I want to shade above the first line and above the second line. And so that would be this region right here. Right? So actually, if I was doing the test point method, I would have got the worst case scenario, because I did this one first. That one wouldn't have worked. This one wouldn't have worked. I wouldn't have found it until here. So sorry, that's kind of being glitchy with this highlighter tool. But you want to shade in the entire region. Now in Math Excel, it has a paint bucket tool. So you click on the paint bucket icon, and then you click in this region, and it just automatically shades the whole thing in for you. All right. So that is how you do all the graphing problems for the Module 9 post-test. If you have any questions and you're my student, please contact me. I hope you found this helpful, and thank you for watching.